I'm going to give you an example of what we're going to talk about. So if I drive from here to my house, and it took me 10 minutes, and I looked at the odometer, and it's 10 miles. How fast did I go?
Really fast.
60 miles an hour? So you're telling me that when I turned left off of 19 onto 1,000, I was going 60 miles an hour?
Should be. 49 average.
Hey, pause.
I could, but I might fucking roll.
So here's my point. So here's my point.
I'd be like this.
Guys, so here's my point. Was I going 60 miles an hour the whole time? Is that accurate?
Yes.
No.
What is 60 miles an hour representative of?
Average.
Average speed or average rate of change. Hey, which means in order to go, I probably had to slow down at some point to turn, which
The speed limit is 55.
which means at some point I had to go faster than 60 miles an hour to balance that out. Probably a lot faster.
See, it does say,
And
it's
it's an example.
Hey,
I can't.
Guys, if I were asking how fast was I going when I passed the cop on 19, you might say way fast, too much fast, right? Too fast. Shush. Hey, I am giving you an example that is theoretical, so no.
From experience of me.
It was an example that I gave you that had easy numbers. So 10 minutes, 10 miles, you came up with 60 miles an hour without doing much math with a calculator or anything like that. So I was trying to make the numbers turn out nicely. Now, you had to go faster than 60 miles an hour. The average rate of change is different than the instantaneous rate of change. Any cop will tell you that. Okay? Now, here's what we're going to talk about. If I want to find the average rate of change, you've already done this. You find the slope. How do you find slope of a line through 2 points? Rise over run. Okay, we might call that change in y over change in x. Okay? If I want to talk about the average slope, I can do that with algebra. If I want to talk about the slope at a point or rate of change at a point, that's calculus. If I'm talking about my average velocity or speed from here to my house, I could say it was 60 miles an hour. That doesn't sound like I went too fast. But if I talk about my instantaneous speed, that I can get in trouble for. Okay? So, here's my point. My point is that instantaneous rate of change has a lot of power, okay? And all of what you are doing in this today is going to be instantaneous rate of change. It is slope at a point, not through 2 points, but at 1 point, okay? How do you describe the slope at a point? You can't do change in y over change in x, but that's still where we have to start. So we're going to start with a graph that has 2 points marked on it. We're going to go with the slope of the secant line, and then I'm going to teach you how to come up with the slope through 1 point, not through 2 points. Okay? It involves a limit, and you're still going to need the slope of the secant line to do that. So you got to know one to be able to do the other. All right? So, hey, here you go. So if this is x, f of x is the y value at the x value. F of x is function notation. It's saying that your function at this x value. It says y value at the x value that's right here. Okay? So let me say that again. This ordered pair is x, y. The y value is f of x. F of x just illustrates the y value at the x value that's listed first. Okay? Now, I'm going h units over. What's the x value of my new point? X plus h. Very good. X plus h. So this is x plus h down here. What's the y value at that new point? How could I express that y value at the new point? Good. Now let me ask you a question. Does the parentheses end after the x or after the h? After the h. So this is f of x plus h. And yes, it matters that you put the x plus h in the parentheses. What you just did is you plug x plus h into your function f. That's not always the same thing. In fact, it's not frequently the same thing as adding h to the y value that you had to begin with. It's not often the same thing. Okay? Now, if I want to express the slope of the line that connects these 2 points, I'm going to do change in y over change in x. So I need to subtract my y values over subtracting my x values. So my 2 y values subtracted, f of x plus h minus f of x. All over what? X plus h minus x. Can I simplify my numerator at all? I'm asking, can I simplify my numerator at all, and if so, how? Can I simplify the denominator at all? Let's go there.
Yeah.
H.
Get rid of the x.
Get rid of the x's. So the denominator comes out to be just h. The numerator doesn't simplify. You can't do anything. You can't like distribute the f or anything like that because this is composition. This is not multiplication. The parentheses here do not mean multiply. You're not multiplying by the function. You are plugging into the function, and that's not able to be distributed most times. Okay, so the numerator actually is still f of x plus h minus f of x. All right, it's just the same numerator. The denominator can be simplified. That's the slope through any 2 points. You haven't done anything different. I just put different letters on it and different notation. That's still y1 minus y2 minus y1 over x2 minus x1. It's the exact same thing. It's the rise over run. Okay, so you count rise over run. That's all you did. Now, what we're going to do is we're going to make that into the slope at a single point. When you write the equation of a line, a straight line, you can put y equals mx plus b. What's the slope? Is it a number or a variable? Does it change for the entire line? Does it matter where you are on that line as to what the slope will be? Nope. Okay, the slope of the line is constant. What's the slope on this curve? Well, that slope looks like it's positive. What's the slope over here? Negative. The slope is changing. It depends where you are on the graph as to what the slope will be. Does that make sense? The slope of a curve is changing. It's varying. And when the slope is varying, when something is varying, we usually involve a variable. So what you're going to do today is you're going to find an expression or formula for the slope at any x value on the curve. And it's going to have an x in it because the slope changes depending on which x value you're on. Okay? So you're going to find the slope at any x value, an expression for the slope at any x value on that function. And here's how you do it. You want to make this difference between these 2 points go to nothing. So you want to make h go to what value? What amount? 0. Good. So you want to make h go to 0. That sounds like a limit. So what I need to do for the slope through a point, the instantaneous rate of change, this gives me the average rate of change. Average slope. Instantaneous slope is different, but related. Instantaneous slope, I'm going to put m for right now, but leave some space right before this because there's actually different notation for what instantaneous slope is. Okay, so instantaneous slope is the limit as h approaches 0 of my secant line's slope of f of x plus h minus f of x all over h. Ladies and gentlemen, this right here is a formula that you need to know. You need to know it. Limit as h tends to 0 of f of x plus h minus f of x all over h. This is change in y over change in x. It's vertical change minus horizontal change, and you're taking the limit as the horizontal change goes to 0 because you don't want the slope through 2 points, you want the slope through 1 point. You want the slope of this line right here. But the x value can change, so it's going to have an x in your answer, probably. All right, now this right here is called the derivative. Derivatives are a really big thing in calculus. Okay, and they allow you to do lots of things. All right. The notation for this is called f prime of x. Okay, f prime is just like a little apostrophe of x, and that means derivative, which is instantaneous. It's not average rate of change. It's instantaneous rate of change. So anytime you see in a problem, what's the velocity at this moment? That's derivative. That's not average slope. You don't want to find the speed that I went over the course of time. You want to find how fast I was going at this minute. All right? We're going to do an example. Okay? That's all notation and in general. I haven't given you an original function to deal with yet. I drew a graph though. Let's say that this is the graph of y equals x squared. All right, now I'm going to do an example, so it's going to have an actual function in it. You're going to be able to do things with these f of x plus h and f of x. Not distribute f, but I'm going to give you an actual function. The function y equals x squared is squaring the x value, squaring the x value you're on. That's the functional part of it. Okay, so here we go. If this is y equals x squared, let's do an example. Let's say I want to find the derivative or find the instantaneous rate of change of y equals x squared. Okay? And it will actually say find the derivative. Of y equals x squared. That's my example. They put it in blue. Okay, so we need to evaluate that, quote, formula, if you will. We need to evaluate the limit as h approaches 0 of this big fraction with subtraction in the middle, and I want more space. Sorry, I'm going to redo this. Limit as h approaches 0 of this big fraction with subtraction on the top and an h on the bottom. The h on the bottom doesn't change depending on which function you're dealing with, so you can actually put it in there before you plug in your functions. Okay? All right, now I need some help. F of x plus h and f of x. If f of x is x squared, if y is x squared, what's f of x? X squared. So I'm going to put x squared to the right of my subtraction. That is your specific f of x. What is f of x plus h? How do you find f of x plus h? F is something squared. To answer your question accurately, is the squared outside the parentheses? Yes. X plus h, the quantity squared. That I like. There we go. X plus h, the quantity squared. That was the whole question of, does the h end before the h? Does the parenthesis end before the h or after the h? You can't just add h to your function value. You have to add h when you're plugging into your function. Okay, this actually changes what you plug into your function. You're not squaring x anymore. You're squaring x plus h. Okay, so this is f of x plus h. If you want to find those two things separately, and actually when you're going through the problem, say f of x is equal to x squared. F of x plus h would then be equal to the quantity x plus h squared. Then you'll have blatant things to plug into your formula for those two quantities. Okay, however, let's try to simplify this. Right now I can't evaluate because I get 0 for h. Do we have the question or no?
Yeah, you want
Okay, so I've given you y equals x squared as your f of x. Any point on this graph, I can find the y value by plugging the x value in. Does that make sense?
Yeah.
If you're going to make a table of values, you could plug in any value for x, square it, and find the y value. Okay, so if you want to list f of x, it's just x squared. Does that part make sense? Okay, then f of x plus h is what's confusing, right?
Yeah, I just don't understand why you're writing it.
So f of x equals x squared. Oh, wait a minute, maybe I
Completely
misunderstood your
different.
question. Evaluating this limit is not different than what we've been doing. Writing this limit as the derivative is different than what we've been doing. Like defining it as the derivative is different. If I would give you this equation in last section, it's the same type of thing. You're still trying to plug 0 in for h, and it still can't happen because you still have a 0 in the denominator. So maybe I didn't understand your question. Do you understand where this comes from?
I'm lost.
Let me work with you afterwards, okay? All right, right here. How do I simplify this? So I've got to get to a place where that h can go away. Plugging 0 in for h, not going to happen right now because I get 0 in the denominator, and dividing by 0 is bad. So how do I simplify a little bit? What can I do? Square. Maybe in a second. I'll keep recording after you leave. FOIL is a great idea. If I FOIL x plus h, I'll get x squared plus 2xh plus h squared minus f of x, which is minus x squared h, all over h. What happens? The x squareds cancel, and then everything you have left has an h in it. And because we're short on time, let's go ahead and cancel the h at the same point. Take an h out of everything, including the denominator. And I was sloppy and forgot my limit notation. The limit as h approaches 0 of this. Everything until you evaluate it. So I'm really taking the limit as h approaches 0 of 2x plus h. Now can you plug in 0?
Yeah.
What do you get? So you're telling me that 2 times my x value is my slope of my instantaneous slope everywhere on this curve. That's what you just found. That's what you just found. 2 times the x value you're on is the slope at the x value on your graph. All right.